Problem F6-6. Determine the force in each member of the truss. State if the members are in tension or compression. Please follow along in the text. In this truss, there are 7 joints, A, B, C, D, and E, and 7 members, AB, AE, BC, BD, BE, CD, and DE. There are also 3 reaction components. There is a pin support at A, which provides reaction in the X and Y direction, and a roller support at C, which provides reaction in the Y direction. There is also a loading force at E that 450 pounds in the X direction, negative 600 pounds in the Y direction. The lengths of AB and BC are given, but the rest of the lengths are not. However, we can see that members A, B, BC, CD, DE, and EA come together to form a 30, 60, 90 triangle, which means that we can use some trigonometry to determine that the height of the truss, and therefore the length of member AE, is 3.464 feet. We can continue this to say that the length of member BE can be given is equal to 4.583 feet, and the lengths of members CD and DE are 3.464 feet. With 5 joints, we can create 10 equations from our sum of force equations. 10 equations, 10 unknowns. This can be solved, but there is an easier way. First, I would like you to consider joint D. Notice that member CD and DE are parallel. If we had selected a coordinate system that was tilted, we could say that both CD and CE were along one of our coordinates, say the I direction, which means that the only thing that can create force in the J direction on joint D was member BD. That would give us an equation, some coefficient times tension in BD is equal to 0. Therefore, member BD is a zero force member. We can more generally say that if there are 3 members at a joint and 2 of them are parallel, the third must be a zero force member. Next, let's look at joint B. At joint B, AB and BC are also parallel. We have also just learned that member BD is a zero force member, which means we could make a similar argument to say that member BE must also be a zero force member. So let's expand our statement to say that if we have a joint that has 2 members that are parallel, we cannot have a situation where only one other member has force. Furthermore, we can say that because these CD and CE are parallel and DB is a zero force member, that the tension in CD and DE must also be equal to each other. By a similar argument, we can say that the tension in AB and BC must be equal to each other. We can take this information and reduce the problem to having only 3 unknowns. One tension that I am going to call tension AC, which is equivalent to the tension in AB and also equivalent to the tension in BC. one tension AE, and one tension CE that is equivalent to the tension in CD and equivalent to the tension in DE. We also thereby eliminate nodes or joints B and D from consideration. This reduces to a problem where there are 6 equations and 6 unknowns. Much easier to solve. Furthermore, we can use the equation sum of forces in E in the x direction to solve for tension CE. Tension CE is equal to negative 519.6 pounds. Knowing tension CE, we can then use the sum of forces on joint E in the y direction to solve for tension AE. And that gives us tension AE is negative 340.2 pounds. Finally, since we know CE and AE, we can use the sum of forces on C in the x direction to solve for the tension in AC, which gives us 450 pounds. And now for our final answer, we again break up AC is AB and BC, CE is CD and DE, which gives us AB from AC is 450 pounds tension, AE was 340.2 pounds compression, BC, which was a part of AC, is 450 pounds tension, BD is zero force member, BE is a zero force member, CD, which was a part of CE, is 519.6 pounds compression, and DE, which was part of CE, is also 519.6 pounds compression.